Hi, welcome back to the channel. In our last lesson, we introduced hyperbolic functions. We saw hyperbolic functions and we try applying them. In this lesson, I'll be introducing graphs of hyperbolic function. I believe after this lesson, you'll be able to draw them freely and also apply them. That said, let's get into class. Now to see the graphs of hyperbolic function, the first we'll be looking at is y is equals to cosh x. Remember that in our last lesson, we said that cosh x as a function or the hyperbolic cos of x is the same thing as e raised to power x plus e raised to power minus x over 2. Remember that we now said that when cosh of x is equals to 0, we'll be saying that this is e raised to the power of 0 plus e raised to the power of minus 0, that's same as e raised to the power of 0 over 2. Anything raised to power 0 is 1. So e raised to power 0 is 1 plus 1 over 2. That's the same thing as 2 over 2, which is equals to 1. So that the cosh of x when it is equals to 0 is the same thing as 1. Today, let's see how the graph will look like and how you can draw the graph naturally. Now, the easiest way we want to look at it is to equate the various value of x. So that when x is equals to 0, 1, 2, and 3. We also see when it's in the negative, when x is equals to minus 2, minus 1, minus 2, and minus 3. At that time, when x is equals to 0, the cosh value of x will be the same thing as 1. When x is equals to 1, the cosh value or the hyperbolic cos of 1 is the same thing as 1.542. So let's get plotting. Now, when x is equals to 0, here's my x-axis. Sorry, I didn't label my axis. Here's my x-axis, and here's my y-axis. So that when x is equals to 0, my cosh is at 1. Here I've put this at 2. So definitely 1 is between 2 and 1. When x is equals to 1, the cosh of 1 is the same thing as 1.52. 1.52 definitely will be between 5 and 2. So it should be somewhere around here. I'll tag this as that point. And when x is equals to 2, my cosh of 2 is the same thing as 3.76. That's somewhere around here. Then when x is equals to 3, my cosh of 3 is same thing as 10 points. That means we have it somewhere around here. Let's look at the negative. When x is the same thing as minus 1, my cosh also is 1.5. That means I still have it somewhere around here. And when x is equals to minus 2, my cosh of the y value is the same thing as 3.76 again. It's not getting to 4. It's almost at 4, somewhere around here. And when x is equals to minus 3, the cosh of minus 3 is same thing as 10 points. That means it's somewhere above 10. It's 10.06, approximately 10. Now, if you look at it this way, I can begin to draw what my cosh of x, and this is how the graph will always look like. This is how the graph will always look like. So that is why we can see that the cosh of x will always look this way with the bowl, let me call it a bowl, facing upwards. As we can see in here, there is the graph of the cosh of x. Now let's look at the sign of x. The sign of x says that when y is equals to e raised to power x minus e raised to power minus x over 2. Let's look at the graph of an hyperbolic function where y is the same thing as sine of x. Now, we'll use the same table, but this time around, we are using a value of e raised to power x minus e raised to power minus x. Now, when x is equals to 0, let's start from x is equals to 0, it tells us that y also is equals to 0. Now, but when x is equals to 1, it is at 1.1. That means it's not up to 2. And when x is equals to 2, it's at 3. That means it's between 2 and 4. Yes, between 2 and 4. And when x is equals to 3, it's at 10 points. That means I have it here slightly above 10 once again. Now let's see what happens at the negative axis. Now at the negative axis, when it is minus 1, when x is at minus 1, my cosh value also is negative. You see, when it's at minus 1, my cosh value also is negative. Now that is at minus 1.11, it's not up to 2. So I'll pick it at this point. And when x is minus 2, when x is minus 2, is at minus 3 is up to 4. So I'll pick it at minus 3.37 approximately. Let me pick it at that point. And when x is up to is at 3, when x is at minus 3, then it is at minus 10. It's at minus 10. That means it's at somewhere below here at minus 10. Now we can easily draw the graph and see what it looks like. It's my free sketch drawing. So here is a graph of y is equals to the sine of x. Y is equals to the sine of x. Now next is we begin to look at the graph of y is equals to the tan of x. Remember, for y is equals to tan of x, we said that y is equals to tan of x. Same way it happens with tan x is equals to sine x. This is going to be the sine of x over the cosh of x. This is the same thing as e raised to power x minus e raised to power minus x over 2, all divided by e raised to power x plus e raised to power of minus x all over 2. Obviously, this will be the same thing as e raised to power x minus e raised to the power of minus x over 2 times 2 over e raised to the power of x plus e raised to the power of minus x. 2 here is 1, 2 here is 1. So that this is e raised to the power of x minus e raised to the power of minus x over e raised to the power of x plus e raised to the power of minus x. Let's get drawing and let's see how it plays. Now I've also created a table for the tan of x so that when x is 0, we have e raised to the power of, or sorry, when x is 0, we have tan of x to be equals to 0. When x is 1, tan of x is 0.762. Now, one unique thing I want you to study about the tan of x is that at each point of these my figures, none of them is above 1. So let's see how it plays in here. When x is 0, this also is 0. When x is 1, you see that 1 is 0.x. When x is 1, the tan of 1 will be 0.762. It's not up to 1, so I'll place it somewhere around here. When x is 2, the tan of 2 is 0.964. When x is 3, the tan of 3 is 0.9. I'll place it here, assume it's not up to 1. Please permit my diagram. And let's get to the negative. When x is minus 1, you see that the tan of x is minus 0 point somewhere around here too. When x is minus 2, the tan of x is also at minus It's also at minus 0.9. That means it's somewhere around here. And when x also is minus 3, the tan of x is at minus 0.995. Now to draw this, you see that the tan of x begin to look like this, passes through 0, now goes down into 1 and comes down this way. Just permit my freehand sketch. So with this, I hope you have an idea, or with this, I hope you now understand how to draw the graph of hyperbolic functions without needing any form of memorization. Thank you for staying with us and see you in our next class.